In association mining, there are two important parameters to check whether an association rule is qualified or not, or to consider the strength of the association rule. Those are called as support and confidence. So it's very important to understand what is support and confidence and how to measure the support and confidence to a given association rule. So we'll take a simple example like this: shirt association with tie. The support is given as 13.5 and the confidence is given as 70%. So when we consider the support for this given association rule, so that means when we take all the transactions where shirt and tie will be involved in 13.5%, that is called the support. When we consider the association, what we do is we filter out the transactions where shirts are available. Out of those transactions, what is the percentage of transactions having a tie inside those transactions? So that is called confidence. So that is given as 70%. So in this given example, the question is ABE is given as a frequent item set, and we need to find out the possible association rules. So given that AB is frequent, that means any combination of ABE is going to be frequent item sets. So we can generate the frequent item sets like this: A association with BE, or AB association with E, AE association with B, and so on. So we'll take another example related to ABE. There's a transaction database given with 9 transactions, and ABE is frequent, and that is given. So we need to generate the association rules with the minimum support of 2 and the minimum confidence is 50%. So given that ABE is frequent, that means it will have the minimum support. So we need to check what are the association rules that has the minimum confidence of above 50%. So when we take an association rule AB association with E, the confidence, we filter out the transactions where we have AB, and then out of those transactions we see how many are there with E. So AB will have in 4 transactions, as you can see in 1, 4, 8 and 9 transactions. Out of those 4, E appears in 2 transactions, that is the first one and the 8th transaction. Therefore the confidence is 50%. So using the same way, we can determine the association rules with the minimum support of 2 and the confidence above 50%. So when we check the association rules, we can see AB association with E, AE association with B, and the rest of the 2 association rules are qualified. And the association rules that does not qualify are A association with BE, the confidence is 33%, that is less than 50, and B association with AE, confidence is 28%, that is also less than 50%. So for any given item set, we can calculate the support and confidence by scanning the available transaction database. So from that we can check whether the association rule will be qualified based on the minimum support and confidence. The a priori algorithm is a popular approach for association mining. We call this approach as a frequent pattern mining approach, with candidate generation, because at each step it generates the possible candidates for that particular item set. So these are the steps in this a priori approach. So initially we scan the given database and generate the frequent one item set. That means each item's support will be determined by scanning the database. So anything infrequent will be removed based on the condition given for support. So using the frequent one item set, we generate the next k plus 1 candidate item set, and when we generate the possible candidate item sets, then we scan the database again and then check whether these item sets are frequent or not. So from that step, all the infrequent items will be removed. Then again we generate the k plus 1 item set. So these iterations will go on until there are no frequent items to be generated or there are no candidate item sets to be generated. So to understand the steps in a priori algorithm, we will take an example like this. So in this given transaction database, there are 4 transactions. In each transaction, you can see there are multiple items. So initially, in this a priori algorithm, what we do is we scan the database and generate the one item set and decide the support. So you can see after the first scan, we can see we generate the one item set. That means we consider a single item and the relative support. So the minimum support is given as a constraint. That means a particular item or an item set should have at least support equals to 2. If it is less than 2, we will consider it as an infrequent item or an item set. So when we consider the one item set and the support, we can see the item D has a support of 1. That means less than 2. Therefore, D is disqualified based on the minimum support. So we filter out the item set. In L1 we can see the frequent one item set is available. So from the frequent item set, we generate the k plus 1 item set. That means 2 item set. So in 2 item set, we can see there are 6 item sets available. Then what we do is we scan the database again to determine the support for this 2 item set. So out of this, we can see AB has the support of 1, AE has the support of 1. So that means AB and AE are infrequent. So we remove AB and AE, and in L2 we can see the qualified item set is available and there are 4 item sets, and using the 4 item sets we generate the possible 3 item set. That means k plus 1 again. So after considering the k plus 1 item set, we can generate ABE and BCE. So when we consider the 2 item set, we can see AB is not frequent. So in association mining, if a particular item set is infrequent, that item set will not be involved in generating any further frequent item sets. So anything that has a subset as AB is going to be infrequent. Therefore, when we consider ABE, based on the AB is not frequent and A is also not frequent, ABE is not frequent. So therefore we generate the ABE E item set as infrequent, and the only qualified item set would be BCE. So when we scan the database again and generate the 3 item set, we can see BCE has the support of 2. So we stopped the a priori algorithm at that point because there's no further item sets to be generated. So this will give you a clear idea of how this a priori algorithm works for a simple example.